Hey guys, let's do our homework. Okay, so our homework was to do this basketball player, state plan do conclude, on a separate piece of paper, like a piece of notebook paper, right? And know that we're not going to be able to use our notes. We'll only be able to use our formula sheet. So that we know that we're practicing this because we're practicing it from memory, right? All right, and then we also have a question for solving for the margin of error. So when we look at this, we did this practice problem in class, and for homework, we were supposed to imagine we're doing exactly the same problem, but instead of 95, we substitute 96%, and instead of a margin of error of 0.03, we're going to substitute in 0.04. Okay, so this gives us a chance to practice how would n change. Okay, so our formula, the margin of error would be our z star times our p hat. Again, they're not giving me a p hat here. So using the most conservative estimate possible, we go ahead and use a p hat of 0.05 unless they give me one, okay? So this would be p hat, 1 minus p hat over n. Okay, so here they changed the margin of error to 0.04. And now I have to look up my z star for 96. So you may have looked that up in class. You could have, so it's like, what is that? So if I add a tab, so I'll put table B AP stats exam, or I could just put AP stats formula sheet. Yeah, AP stats formula sheet on AP Central. So I look through my formulas and I say, oh, okay. I see this confidence interval is my statistic plus or minus critical values times standard error. I see some of these formulas are starting to look like I know what I'm doing. Okay. And I get to my table A and I get to my table B. And I notice at the very bottom of table B, it says confidence level, and the number above it is not 1.960, it's 2.054, 2.054. Okay, so my z-score is 2.054. All right, so if I got to be more confident, I've got to make that wider, right? And then this, and then that's what I'm solving for. Okay, so we can type this in our calculator. We find the in solve button and we type in exactly what we see here. And then we put comma n and hit enter. And this should give us an answer. But I'm sitting at home and I don't have that calculator with me, so I'm going to go ahead and do it by hand. So the first thing I'm going to do is divide by the critical value on both sides. So now I'll have this number. Right? And on this side, I'll have this number, right? Then I'll square both sides. Okay? Then I'll swap the spots of these two. I'm going to swap spots. So that would be n is equal to 0.25 divided by this. Okay, so now I just have to figure out how to type that big yuckiness in a calculator. So let's go to a calculator. I'm just jotting it down so when I get to the calculator I can kind of see the numbers. And where's my calculator? I've got a lot of apps on here, don't I? Here it is. Okay, so in my calculator app, it is, I'm going to work with the denominator first. It is 0.4 divided by 2.054, enter, and I'm going to square that. Okay, so that's the number in my denominator. Now, if I flip that number upside down, I'll make it into the denominator. So I'm going to hit that button. That's that number flipped upside down. Okay, so when I multiply by 0.25, I get, so that doesn't make sense. Let's try that again. So 0.04 divided by 2.054. Enter. Square that number. Now that makes sense. Flip it upside down. Okay, that number makes sense. And now multiply it by 0.25. And we get 659.2. 659.2. And we learned in class that we would have to round that up because we can't talk to that many people. All right, so we need to be able to do that for the test, and we also need to be able to state, plan, do, and conclude by heart. Yes, with our formulas, but no, not with our notes. So in a calculator, before I left class today, I typed this into my big yellow TI Inspire and got that. I'm also going to show you how to get this same information off of a website calculator. So if I go to a website calculator, here we go. And it says a confidence level. And so our confidence level, let me go back to my notes. We're doing a 99% confidence level. And I had 31, I made 31 out of 50. Okay, so 99. And I had 31 successes out of a total of 50. And that number at the top just tells me how many decimal places. Okay, so it looks like I got the same confidence interval. Do you see how mostly those numbers are? So if I switch to 2 decimal places, test the calculator, yeah, pretty much get the same confidence intervals that I got before. Right, so everybody sees I got 0.44, 0.80. We'll go back to the screen, 0.44, 0.80, because we use normal approximation, this one, normal approximation. Okay. So now we're going to do all the stuff we need to do. All right, and I suggest you use your notes to compare. So side by side, you're going to use your notes and tell me what you're going to do. So we will perform, we're going to estimate. We're going to estimate P, which what does P stand for? That's my parameter, the true, and then I got to see what it is we're finding, right? The true proportion of free throws Miss K would make. The true proportion of free throws Ms. K would make. Okay, that's it. And then we want to say at what level? At a 99% confidence level. All right, plan. Well, the plan here would be to do a 1 proportion. I only have 1 proportion, Z interval for P. So on my TI Inspire, this is the button I'm going to pick. So if you're not sure where to go, you go to menu, then stats, then you'll see confidence intervals on there. And you'll scroll down till you see 1 proportion Z interval. Okay? Nice. So what's next? We want to do R, N, and I. And we clarified today in class that R stands for random, N actually stands for normal. Can we use normal approximation to get this information? And I is independent. So let's look in the problem if we can identify something that's random. It says, yep, those were taken. The shots were, yes. It's random. Because it says it was a random sample. Okay, easy enough. Normal. Do I have normal? Did I ask her to take enough shots? Right? So I'm going to say yes, it's approximately normal. My sampling distribution. Because I have at least 10 yeses and nos. What do I mean by that? N times p hat is greater than 10, and n times 1 minus p hat is greater than or equal to 10. Meaning we took 50 shots and the proportion of subs were 31 out of 50, meaning 31 went in. That's greater than 10. And then 50 times 29 or 19 out of 50 is the proportion, 1 minus 31 over 50. And that means that that would equal 19, right? And that's definitely greater than 10. So at least 10 shots went in and at least 10 shots did not go in. So do we have independence? Yes. Yes, we have independence. Yes, it's independent because it's reasonable to assume that the population, and you're like, wait, let me look at the context. The total shots of all the free throws she's ever taken. That's the population. Free throws. If she really is supposedly a good basketball player, and I played in high school, and I'm still good, then it's safe to assume that the population is greater than 500, right? And that's 10 times n. I've taken more than 5,500 shots, right? Okay, let's do it. This is the formula. We will have a formula sheet, so we won't have to memorize this, but we'll have to know when and where to put what. This is our point estimate plus or minus our margin of error. Okay, and we already have had a calculator generate that for us. So we end up getting 60 plus or minus 0.8. Okay, that gives us the interval 0.44, comma 0.80. Okay, so let's just plug in these values. We know that this is 0.62 plus or minus. Ooh, what happened there? Plus or minus our z star, which we need to look up for 99. Okay, so back to our table. When we look this up for 99, we see that it's 2.576. Okay, that makes sense. 2.576. 2.576. 62. 19. Be 38 over n. What is n? We know it's 50. Okay, and the calculator told us that's this. Good to go? All right, so we're down to the last step. Sometimes I like to do this one first because it's so exciting. We announce we are 99% confident that the interval from blank to blank captures the yada, yada, yada. So we go up here for our yada, yada, yada. What does it capture? It captures the true proportion of free throws Miss K would make. And what is blank to blank? Well, again, we got this from our problem. So I know that based on the samples she took, that her real shot record is somewhere between 44% and 80%. That's a big range of numbers there, right? But again, this is a very high confidence level, so that should make sense. Thanks for joining me, guys. Good luck on the test. Take care.